Hello Math 1010, this is a video for section 10.3, and in this video we will be simplifying radical expressions. So the first thing we need to see here is, if you see at this first equation here, we've got the nth root, meaning any kind of root, with a underneath, multiplied by any kind of root, well, it has to be the same root as the previous one, with a b underneath. Then you can bring them underneath a single root, or radical, that's another name for it, and multiply those two things. So go ahead and see if you can do that on a practice A, kind of apply that principle on practice A, and we'll see if you get it correct. So if you take a look at practice A, we've got the cube root of 9 times the cube root of 3. That means we can do the cube root of 9 times 3. And we know that 9 times 3 is 27. So we have the cube root of 27, which actually now simplifies to just 3. So that turned out nice, whereas before it was not nice, because the cube root of 9 is not a nice number, and neither is the cube root of 3. But the cube root of 27 is. We take a look at the next one, and this one would just be the square root of 21x. Nothing really simplifies there, so we'll keep it how it is. And then on number C, or letter C, we've got the square root of AB on top, and then 3 times 5, which is 15. So square root of 15 there. Okay, so this helps when we are trying to simplify a root. So if you take a look at example 1, it says use the product rule to simplify. In order to do that, we're going to go backwards. Rather than taking the root and having it separated by, or taking two roots and having them separated by multiplication and bringing them into one root, let's take this root and separate it into two roots, so that we have a square root here and a square root here. And if we're clever, we can make it so one of those square roots is a nice square root, or a perfect square. Because the square root of 24, that's not a nice number right there, not a nice perfect square. However, inside of 24 is a factor of 4. And 4 is a perfect square. The square root of 4 is 2. So let's put 4 underneath one of the square roots, and that means that 6 is going to be underneath the other square root. So if we do that, then we have 2 square roots of 6. And your calculators are also really good at that, actually. So I don't know if you've actually had to learn this in other math classes, because your calculators do that very well. But it will help us to do some other problems this way. So if you take a look at the next one, letter B, square root of 200, well, that's not a nice square root. You might think 100, but 100 plus 100 is 200. 100 times 100 is not 200. So let's instead think of what is a perfect square that is a factor of 200. And we actually just kind of identified it. Even though 100 is not the square root of 200, you can take 200 and separate it as 100 times 2. The reason we want to do that is because 100 is a perfect square. So the square root of 100 times the square root of 2, if you split it up, the square root of 100 is 10, and then the square root of 2 just stays as the square root of 2 because it is not a perfect square. So if you notice, we're trying to find factors of the number inside that are perfect squares, and then when you find that, it can simplify. However, if you look at letter C, that is not a square root, it is a cube root. So instead of looking for a perfect square that is a factor of 24, we want a factor of 24 that's a perfect cube. And if we think real quick about some of the perfect cubes, we're not as familiar with those as we are perfect squares. 1 is a perfect cube, and then 8 is a perfect cube because 2 times 2 times 2. And then 27, 3 times 3 times 3. 64, 4 times 4 times 4. And then, let's see, I think it's 215. Let me grab my calculator real quick. Sorry, 125. I was thinking of a different one. 125 is a perfect cube, and then they just start getting bigger. So I mainly know, obviously, as you saw, I mainly have these ones kind of in my memory bank, and then anything other than that I will use a calculator for. So 8 is a perfect cube, and it is a factor of 24, because 24 is 8 times 3. So we'll go ahead and split that up. So it's the cube root of 8 times the cube root of 3. And then the cube root of 8 is 3, or is 2, excuse me. And then that'll be multiplied by the cube root of 3. So that should be the answer on that one. 2 times the cube root of 3. So go ahead and pause the video and see if you can do practice B. Okay, so let's take a look at practice B. The factor of 18 that is a perfect square is 9. So we can say 9 times 2. And then that would be the square root of 9 times the square root of 2. And then that would be 3 times the square root of 2. And that's what your calculator should give as well. This one, 2 is on the outside, so just kind of ignore it for a little bit. And then 75 has a factor of 25 that is a perfect square. So we can split that up, so it's 2 times the square root of 25 times the square root of 3. And then square root of 25 is 5, and then we have square root of 3. And now that 2 that we were kind of just tagging along the whole time, that can be multiplied by 5. So 10 times the square root of 3. And then 54, it's a cube root, and a factor of 54 that is a perfect cube is 27. It's 27 times 2. So we can split that up to be the cube root of 27 times the cube root of 2. Cube root of 27 is 3, and then we have the cube root of 2 that it's being multiplied by. So those should be our results and our answers for the practice problems and for that example 1. Let's go ahead and keep going. Let's take a look at example 2 and practice C. So now we can't just use our calculator because we've got some variables in there. So if we think about this, we can split this up. So it's the square root of 25 times the square root of a squared times the square root of b cubed. Now this isn't too bad because the square root of 25 is 5. And if you look at that, the square root of a squared, so since the square root undoes things that are multiplied by themselves, the square root and the power of 2 will undo each other. And you'll just be left with a. So that'll be 5a. However, if you look at the next one, we have b cubed. It's not b squared. So that could be kind of tricky. However, if you think about it, that's the same thing as b squared times b. And when you do that, now you can see that the square root and the square do undo each other, but it leaves one of the b's left over inside the square root. So the final answer on this one will be 5ab square root b. If we take a look at the next one, it's we're going to apply some similar reasoning. So the cube root of 64, we can split that up. So cube root of 64. and then times the cube root of x to the 6th. Well, x to the 6th can actually be thought of or rewritten as x cubed times x cubed. So what if we change this to the cube root, to the cube root of x cubed times the cube root of x cubed, right? Because x cubed times x cubed would be x to the 6th. So therefore, now the cube roots and the powers do undo each other because they match up. And the cube root of 64 is 4. So we would just have 4x squared on that one, because we would have 1x come from here and 1x come from here, and x times x is x squared. So that would be the result on that one. Letter C, let's see if we can tackle that. So we've got the cube root of 54, and then let's split it up. So it's the cube root of x to the 6th times the cube root of y to the 8th. Now, 54 isn't a perfect cube, although we did just do it on the previous practice. We know that that can be rewritten as 27 times 2, so that'll help. And then let's rewrite x to the 6th as x cubed times x cubed. And then let's also do that with the y's. Gonna run out of room here. Y cubed times y cubed, and then times cube root of y squared. So notice how I've got 3y's here, 3y's here, that would be 6y's, and then I have 2 more y's to make 8y's. So it looks real messy, but if we clean this up, we know that the cube root of 27 is 3. So that's going to be multiplied by the cube root of 2. And now the cube root of x cubed leaves us with x. Cube root of x cubed leaves us with x. Cube root of y cubed leaves us with y. Cube root of y cubed leaves us with y. And then this last one, nothing cancels there because we don't have enough y's. So that's going to stay like that. So we've got x times y times y times the cube root of y squared. So one last thing to do here is anything that does not have a root, or anything that is not inside of a root, can be written first all the way to the left. So 3x squared y squared. And then actually that 2 and the y squared, as we learned on like the very first practice, we can make those go underneath one root, and it just looks a little cleaner. So we'll put them both underneath the cube root, and that would be our final result on that one. Sorry, there's not a ton of space here. Little thick on my pen I'm using, my digital pen. Okay, so go ahead and try practice C, and let's see what you can do. Pause the video and do practice C. All right, if we take a look at practice C, we can split this up. So it is the cube root of 27 times the cube root of x cubed times the cube root of x cubed times the cube root of x cubed. And then we can keep doing that for the y's. However, do you notice how there would be 5 y's left over when you split up the 15 into 5 groups of y to the 3rd? So that would leave us with 3x cubed y to the 5th. So if you've noticed that root, whatever root it is dividing the power by that root. So it's a cube root that divides the 9 into 3. That's why we have x to the third. And cube root divides 15, and that leaves 5, so that's why we have 5 there. So that's also kind of a way you can do it. Okay, if you look at this one would be the cube root of 27 times the cube root of 3, because 81 has 27 as a perfect cube. And then that would be times the cube root of a to the 12 times, kind of running out of space here, times the cube root of, that's b to the 14. 14 doesn't divide by 3 evenly. So what if we make it b to the 12 times the cube root of b squared? We did that on kind of a couple of problems, like on problem A, we did that with the b's. So if we simplify this now, cube root of 27 is 3. Cube root of 3, that's just cube root of 3. And then cube root of 12, 12 divides by 3 evenly and gives us a to the 4th. And then b to the 12, that simplifies and gives us b to the 4th. But then we have b squared that is still in the cube root. So we'll write it as b squared inside there. And then as we did on letter C on example 2, anything that is still inside a root, let's put it all inside the same root. So cube root of 3b squared. And then let's go ahead and box some of these in so it's kind of clear. My work is a kind of a mess, not as good as it is on the smartboard. And then for letter C, we've got the negative square root of 72. 72 has 36 as a perfect square, and then times by the square root of 2, because 36 times 2 is 72. And then we can do the times the square root of x to the 10th power. And then 10 divides by 2 evenly, so that's fine. However, y to the 15, 15 does not divide by 2 evenly, so let's make it y to the 14 times y. That would be 15 y's. So then this will reduce to 6 square root 2 x to the 5th, and then y to the 7th, and then still times the square root of one of the y's. And then anything that's still in a root, let's put it inside one root. So negative 6x to the 5th, y to the 7th, and then times the square root of 2y. We can put the 2 and the y inside the same root. So it just looks a little better. And that's what we would get on practice C. Okay, if we take a look at the quotient rule, it's kind of the same thing, but it says that you can do it when things are being divided. So the product rule says you can split up the root with multiplication. You can also split up the root with division. Either split it up or make it one root, which is actually what we're going to do on example 3. If you take a look at example 3, it's the square root of 20 divided by the square root of 5. Since those are the same kind of root, we can make it one root and say it's 20 divided by 5, which is nice because 20 divided by 5 is 4. So we have the square root of 4, which becomes 2. Let's go ahead and do that on the next one. We've got square root of 50 x divided by 2 times root 2. So since that first 2 is not in a root, I'm going to write it as 1/2 times the square root of 50x divided by 2. And now 50 divides by 2 to give 25, so we have 1/2 square root of 25x. And then 25 is a perfect square, it's 5. So that'll be 1/2 times 5 square root x. And then that probably works, but it also might be nice to say 5/2 square root x for our final answer. Go ahead and pause the video and do practice D. Okay, on practice D, let's see, this should have a square root there. You can rewrite that so that both of them are inside the same square root. So the square root of 48 divided by 3, and that is 16. So the square root of 16, and that would be 4. And then on letter B, we can rewrite it as the square root of x to the 11th, y to the 5th, all divided by xy. And then that'll simplify because the x to the 11th will simplify with the x on the bottom and leave you with x to the 10th. And then y to the 5th on top will reduce with the y on the bottom and leave you with y to the 4th. And then since those are in the square root, you can divide those powers by what kind of root it is, which is a square root, so divide them by 2, and you get x to the 5th y squared. So that would be the result on practice D. All right, let's go ahead and take a look at example 4. So this time, they're being divided inside the same square root. Let's go ahead and split it up with the root. So let's write it as the square root of 25 divided by the square root of 49. Because now the square root of 25 is 5, and the square root of 49 is 7, so we would have 5/7 there. This next one, if we split it up, it'd be the square root of x divided by the square root of 9. Square root of 9 is nice, that's 3, but square root of x is not, so we can't really do anything with it. We'll just keep it how it is. Let's split this one up, and it's a 4th root. So 4th root of 3 divided by 4th root of 16y to the 4th. 4th root of 3 does not simplify any further. However, the 4th root of 16 is 2. And then the 4th root and the power of 4 match up perfectly. So we should be left with y on the bottom on that one. Go ahead and pause the video and do practice E. Okay, if we take a look at practice E, we've got the square root of 36 divided by the square root of 121. Those are perfect squares, so we get 6/11. And then this one would be the cube root of x divided by the cube root of 8. Cube root of x cannot really go any further, but the cube root of 8 is 2. And then we've got the 4th root of 5y divided by the 4th root of 81x to the 8th. The top does not really simplify. However, the bottom does. 4th root of 81, that's a perfect 4th root. It's 3. And then 8 can be divided by 4 evenly and leave us with 2 as our power for x. So we've got 3 and then x squared on the denominator. Okay, let's go ahead and take a look at the next topic, which is the distance formula. So it says the distance between 2 points on a coordinate plane can be found using this formula. So what we're talking about here is if we have an xy axis, and if we have 2 points like right here and right here, because they're at a diagonal, that might be hard to find what the distance is. But since we know that those points are going to have a coordinate, like an x and a y, then we can use this distance formula that says take the second x coordinate and subtract the first x coordinate, and then take the second y coordinate and subtract the first y coordinate, square those results, add them up, and take the square root. And that would be the distance in between them. So let's take a look at example 5. Find the distance between -5, 8 and -2, 2. So the distance would be the square root of, let's go ahead and label these. So let's say that's x1 and that's x2. And then this would be y1 and that would be y2. So x2 minus x1 would be -2 minus -5. And then that gets squared. And then we add to it 2 minus 8, and that gets squared. And you can put it into your calculator from there, but if we wanted to try some mental math, we would have 3 squared plus -6 squared, and so that would be square root of 45, which then can then be reduced to 9 times 5, because 9 is a perfect square. So we have 3 times the square root of 5 for our result, our final answer. Go ahead and pause the video and do a practice F. Okay, so for practice F, this would be x2, that's x1. This is y1, and that's y2. So using the formula, we can do the square root of 1 minus 2 squared plus -4 minus -5 squared. And we end up getting the square root of -1 squared plus 1 squared. And that is just square root of 2. So that's how you can use the distance formula to find the distance in between 2 points. And the last page, if we take a look at the midpoint formula, so this is also talking about 2 points on a coordinate plane. So if we've got 2 points on here, then the midpoint would be asking for the exact point in between those 2 points if you were to draw a line segment between them. So what is that exact point there in the middle? And this is how you calculate it. Notice how it is an ordered pair in this formula. So like this is the x value of the midpoint, and this is the y value of the midpoint. So it's an x and a y. Let's go ahead and do the first one. Example 6, find the midpoint of the line segment. So this again is x1, that's x2. This is y1, that's y2. So if we take a look at our midpoint formula, it would be x1, which is -5, plus x2, which is -2. That's all being divided by 2. And then y1, which is 8, plus y2, which is 2. And that's all being divided by 2. So this would be -7/2. You could say -3.5, but I like to keep it as a fraction. And then that actually works out nicely on that one. So negative 7/2 and 5 would be the x and the y for the midpoint in between those 2 points. Go ahead and pause the video and do practice G. Okay, so for practice G, we should have negative 3 plus 1 divided by 2 and 3 plus 0 divided by 2. That would give us an x value of negative 1 and a y value of 3/2. That would be the point that is in the middle of those 2 points, negative 3, 3, and 1, 0. And that is section 10.3.